if bisectors of opposite angles, so we are looking at angular bisectors of a cyclic quadrilateral. So we have cyclic quadrilateral. So what is the property of a cyclic quadrilateral? Yes, the opposite angles add up to 180 degree. Intersects the circle, circumscribing it at the point P and Q. Prove that PQ is a diameter of the circle. Now we have a cyclic quadrilateral. Let me draw that first. So the vertex is on the circumference of the circle. So let me consider two angles, and those two angles should be opposite. So this is the first angle, this is the second angle. And now if you bisect it, so if I bisect it, say this line is bisecting, let me change the color. This particular line is bisecting that particular angle, and this particular line, it's somewhat bisecting, right, that particular angle. So joining these 2 points will give us the answer. Let me explain this. See here, I'll draw, just a second. Okay, I'm trying to draw a better diagram, that's all. Okay, so we have the two angular bisectors. They are intersecting the circle at P and Q. So that's P and that's Q. And this is A, B, C, D. So here we are considering D and B to be opposite of each other. They are bisected with PB and DQ. The point wherein these two bisectors meet, PQ, that is, if I join them, they're telling that by default it will pass through the center of the circle. So this is what we have to prove, right? So let me write what is that we have done. So we have a diagram wherein we have our diameter PQ. We have to actually prove that it's a diameter, and we have ABCD to be the cyclic quadrilateral, and we have PB and DQ to be the bisectors. Anyways, all of this is described in the question. We don't have to write exclusively. So what is that we have to prove? We have to prove that PQ is a diameter. Just a second. We have to prove that PQ is a diameter. Okay. What next? How will you prove something is a diameter? Well, it is the biggest chord. That's good. In terms of angles, is there anything particular that we know? Yes. Think about it. It's over here. Angle subtended by a diameter on the circumference of a circle is 90 degree. What does it mean? If I happen to join something like this, right? This by default is 90 degree. So for example, so this is a right angle triangle. Okay, this particular thing is a right angle triangle. If you prove that it's a right angle triangle, we are done. So basically the angle which it is made up of, so it's made up of this particular angle and this particular angle. If you prove that this two adds up to 90 degree, we are done. So we have to do a bit of construction, that is to join things, nothing much. So we happen to join construction, right? We join DP. Next is what? Okay, so we have a bit of more construction that we might need, so I'll leave some space. Next is proof. So as usual, whenever we have bisectors, what do? I'll call let that particular angle, like in this case ABC, be equal to 2x, and EDC is equal to 2y. Okay, so this is x and this is x, this is y and this is y, right? So that we have to write it again. Therefore, angle PBA will be equal to angle PBC. Okay, this x part will be equal to half of ABC. This is basically equal to x. Okay, so the reason being, this is because of PB is a bisector of angle ABC. Okay, so making it very clear. Next is, what do we have? We have angle ADQ is equal to angle DQDC will be equal to angle ADC by 2 will be equal to y. So this is because of DQ is a bisector of angle ADC. Okay, what next? So somehow I have to relate. See, the relationship between 2x and 2y is quite simple. Since it's cyclic quadrilateral, right, we'll tell as ABCD is a cyclic quadrilateral, right? What are we looking at? We are looking at 2x plus 2y is equal to 180. So on dividing this entire expression with 2, x plus y is equal to 90 degree. Is it not? The reason being, as opposite angles, because opposite angles of a cyclic quadrilateral adds to 180 degree. Okay, right? So that is the reason. Now, so basically I just found that x plus y is 90. So what should be our agenda? This is y. So this has to be x for us to prove that we have PQ as a diameter. So how will I prove that this particular angle is equal to x? That's the whole funda. If I'm able to prove that, we are done. So we should look for one chord which will kind of not join them, relate them. Which is that chord? Think about it. So let me show this to you guys. We are looking at this particular angle. See, I'm just joining. Okay, I'm just expanding to the circumference of the circle and so on and so forth. And we're talking about this particular angle. We want to relate this to. So which is the common sector? Think about it. Let me change the color so that it's kind of visible. So this particular angle. Yeah. So what is the section which is overlapping? Yes, PA. So we'll also join. We're going to also join PA. And so this is a chord wherein we have ABP and ADP being subtended on the circumference of the circle. So basically these two angles are equal, is it not? So we'll tell this. So we need the diagram actually. Let me kind of copy this off. If not, back and forth. Okay, so we have this particular diagram. Let me copy this. Okay. Now, so we have angle ABP is equal to angle ADP. Both are equal to x. Why is it so? Because of, yes, angles in the same segment of the circle are equal. Because of angles in the same segment of the circle are equal. Okay, And now finally we have angle PDQ, which is equal to, it's made up of angle PDA plus angle ADQ. So this is x plus y. But from 1, what do we have? Clearly from 1 we have the following. So from 1, this entire thing is equal to 90 degree. This is from equation 1. So this is 90 degree, which is, this is 90 degree. Okay, so this is 90 degree, and what do we have? Yeah, one last thing is we need to prove that PQ is a diameter, as angle PDQ is equal to 90 degree. This implies PQ is a diameter, because only diameter will subtend an angle of 90 degree with the circumference of the circle, is it not? As diameter is the only chord. Again, there's a lot of writing we have to, that subtends an angle of 90 degree with the circumference. Right? So this is your answer, hence proved.